Okay. Hi, sir. Hello. Welcome to the third training of Wecon PLC. I'm Theodore, and in today's training, I'm going to introduce the high-speed pulse output of our PLC. So it's mainly divided into four parts. Part one is origin return. Part two is absolute relative positioning, and part three is PWM instructions, and part four is multi-speed positioning. Okay, the first one. Hi, sir. Which about the first one, the instruction is JRN and DJRN is origin return. This instruction is This instruction is use the specified pulse speed and the pulse output port to make the actuator move to the origin of actions. Dot point. When the PLC and the servo driver work together until the origin signal meets the conditions. And about the parameter, there are four parameters. The first one, S S1 is the speed when the origin return start, and we can see there are two range of in here. And the first range is belong to JRN, is 1 to 32,000 and 767, and another range is 1 to 200,000. It belong to DJRN. So JRN and DJRN, the difference is the DJRN there is a big range of data type. So JRN belong to side being 16, but DJRN is has the size being 32 data type. So there is a different. And the second parameter is S2. S2 means the cross speed. Uh, Cross speed, it means that when PLC receives the dog signal from the S3, S3 means dog signal, and the servo will switch the running slowly at the crawling speed. In general, we will set the crawling speed to be less than the running speed. Okay, so S3 is the device number of the input number of the near point signal. Is a dog signal to be input. So, and finally, parameter is the D. D means the device number Y, and the let output pulse. And about this instruction, only Y device with the positioning parameter could be specified, and after the dock connect the signal of these instructions, the pulse stop immediately, and the pulse in a pulse frequency could be modified during the PLC running. Okay. Look at this. Look at this picture. The first is S1 parameter. S1 specify the speed at the start of return in S1, and it could be in the range of 1 to 200,000. And the second parameter specified the crawling speed in S2. So there is a third parameter, dog connect. So this picture is when the origin return function is start, and the motor will running according to the origin return speed, and when the dog signal is on, is detected, the motor run according to the crawling speed until the dog signal is disappeared. So then the turn off arranging function automate altered. So let's look at the demo for the JRN and the DJRN. So in this program, first we set Y1 as the output axis at a maximum speed of 2000 K and the offset speed of 500 and acceleration time and the deceleration time of the 100 million seconds. So ranging return is performed at the 5 Hertz, and when um, we trigger the origin signal by X2, then it will the motor will running in the crawling speed. We set this speed in 1 Hertz. So let's see when I trigger M0 picture, and first it will running in the 5 Hertz, and then when the X2 is dog signal, it will be triggered, and then servo will running with the 1 Hertz. Okay, now dog signal is triggered. The speed is slow. It's different. The first speed in 5 Hertz when X2 dog signal is triggered, and the speed is slow in crawling speed. And when signal is off, the instruction is stop. So this is the DJRN and the JRN and the DJRN's function. Another function is the DSJR and the DDSJR. In short, the instruction is that when PLC works with the servo driver, it uses the specified pulse speed and the pulse output port and the specified direction exit to move the actuator to the origin of the actions, a dog signal, until the origin signals meet the conditions. And in short, the function of this instruction is similar to the JRN instruction. We just introduction introduce. So the difference is this one, this 4 parameter is the same with JRN. It's the same. And the difference is here. DSJR, this parameter, this instruction, and has more parameter than JR instruction, and can be used to control the direction output. So this is the different from different from JRN, and the D is the same, means the bigger range. And the second difference is the DSJR instruction is only supported by the LX5V. LX3V cannot support the DSJR instruction. So there is two different compared to the DJR instruction. In the DSJR, this instruction, we need to choose the origin return mode. Back to the origin. Kindly, we can kindly check here. This is our website link. Uh, Let me change. Okay, now I change in the information in our website. First, we need to determine the output pulse terminal. For example, if I choose Y0, then we set the required back to origin return mode in SD 1914. For example, we can set if we set this register to 0, it means the PLC running origin return mode in 0. And there is a origin return 1, origin return 2, origin return 3. So there is four different origin return mode. First, we need to choose which origin return mode you want to running in the PLC. And the second is origin return distance. If set the distance of origin return, but no please note that this parameter is not required for all modes. For example, origin return mode 0, there is not origin return distance in this mode. But origin return 1, origin return mode 1, there is a origin return distance in here. So we need to pay attention to here. For example, if I choose model 1, if I choose model 1, when the origin function is start and the servo first reverse at this time. Oh, sorry. The servo first reverse and at this time the dog signal is on, and the servo will slow down and stop, and then the runs origin distance we set in here because we choose the Y0, so origin we need to set the origin return distance in here. This SD 919 and 918. And if the servo will run origin distance we set when the motor we set the distance, and it will reverse direction again and stop when the dog signal is detected. So this is the origin return mode in the DSJR instructions. So let's come back to so look at the example program. In this demo, the origin return mode, we choose the mode 1, this picture. And up the dog signal is actual. It reserves by the specified origin return distance is SD because we choose the white one. And then the search for the origin position and the clocking speed. This process This process continue until the signal S2 is received again. It will point Y1 stop and emitting pulse. Let's see. Please wait. Okay. When the embedding is triggered is on, and the first is running with the 5 Hz, and then X2 is triggered. It running in the clock speed. This is we set the return distance, and if the instruction finish the oriented distance, he will running reverse again. And when the S2 is triggered, the instruction will stop. So this is the DSJR. The DSJR and the JRN actually the functional is very similar, but the DSJR is there is a direction can control, and it can support in the LX53, and it can support choose the origin mode. If we can refer in here. This is our website link. Okay, so this is the first part. About these two instruction, is there? Do you have any questions, sir? Okay. About the part two is absolute or relative positioning. The first instruction is DVIT and the DDVIT. Instead of saying D means the big range, side being 32 data type. And this function, this parameter, this instruction output the specified number of pulse according to the specified port, frequency, and the running direction. When an interruption signal is received, it will stop after sending the specified number of pulse. There are 5 parameters. The S1 parameter means the specified the number of output pulse, and the second S2 parameter means the specified frequency output pulse. In short, this one is number of pulse, this one is speed of pulse. And D1 means the specified output pulse port Y1, Y2, Y0, we can choose. And D2 means the running direction output. And D3 means the interruption signal. Look at this. When the function is start, function is triggered, the output axis start to acceleration and run at the instruction speed we set in the S2. And when the interrupt signal is triggered, it just the recent age is okay. When the interruption is triggered, the instructions run at the set number of the pulse. So here is a question. If I trigger the interrupt signal several times during the instruction is running, so what will be the result? So the answer is that there will be not effect because this instruction will running normally according to the first times the trigger signal. And this is the pulse sending flag and the pulse stop flag. For example, if we choose Y0, the bit switch is SM A118 and A182. And this one is the demo program. For example, we set Y0 as the output axis and Y1 as the direction axis with the maximum speed of 100 hertz, and the offset speed is 0, and the acceleration time and the deceleration time is 100 milliseconds. This is the initial parameter we set in here, and then run at the frequency of 100 here, 100 hertz, and send the six pulse 600 pulse after receive the FM signal. FM signal is the interruption signal. So let's see the demo. When a function is triggered and the value of the SD SD 818 is greater than 500, and then the interrupt signal will be triggered, and the PLC will send the 600 pulse and stop automatically. So the totally number of the pulse is 600 at the as this is the totally number of pulse. Okay, you can see first trigger and the instruction is running. When this it will be triggered FM 5, and it will run 600 and it will stop. So finally it is pulse is 1100. See this? And there is a little high speed. So this is about the VDIT and the DVIT and the DDVIT function. About the DRVI and the DDRVI is this instruction is relative positioning. Relative. Wait, I change. Okay. Executed signal speed positioning instruction is in relative drive mode. The method of the specifying the movement distance from the current position with the positive or negative signal size is also called incremental drive mode. There is four parameter. The first one parameter S1 is means that specified the number of output pulse is absolute address, and second S2 means that specified the frequency of output pulse. D1 means specified the device number of output pulse, and D2 means the running direction output port or bit available. About the DRVI and the DDRVI, the most important point is take the current stop. The current stop as a start point, unlike the absolute position instruction. The start point is of the relative position instruction is not fixed. So, for example, if I start from the zero orange and then I move the ultimate is 100 pulse, and then I trigger this instruction. I trigger this instruction again. It will in the run, and it set the 100.8 is the new origin and running again. So the totaling pulse number is 200. So this is the relative positioning. Let's see the demo. First, we set the y0 as the output axis and the y1 as the direction. And the maximum speed is 200k, offset speed is 500, and the acceleration time is 100 million seconds. In here, this is the initial parameter. And then send the high-speed pulse with the acceleration and the deceleration at a frequency of d 400 value, and the pulse number is of the d 300 value. It's two parameter. Okay, let's see. Wait a moment. When I trigger, first I running this parameter on this instruction, and the SD, the result is 2000 because we set the pulse number is 2000, and then I change this parameter to negative 1000, and I trigger again. The result is the 1000 because this instruction is a relative position. So the start point is the current point, and the second instruction is DRVA and the DDRVA. This is different from DRVI and DDRVI. DRVA means the absolute positioning. So this instruction is execute the single speed positioning instructions in absolute drive mode. The method of the specifying the movement distance from the origin zero is also called the absolute drive method. So there are four parameters. First, S1 means the specify the number of output pairs. So this is the number of pairs, and S2 means the specify the frequency of output pairs. So this one is speed is the same with the DRVI, and the third is D1 means specify the device number of output pairs, and the D2 means the running direction, output, port, or bit available. So let's see the this different from the DRVA and the DRVI and the DDRVI. This is absolute. So it means there is only one origin point. This is zero. Let's see this. For example, I trigger when I set the 1000 pulse, and when I trigger this instruction, the result is 1000, and then I change this to negative one. When I change this parameter to negative 1000, You can see uh, so because the result is 200. Let's see again. First running and the result is 1000 is not. And then I change this parameter to negative 1000 and trigger again. It will slow down to 0 and negative to the 1000. So this is the absolute positioning because it means there is only one origin point. It's just the 0. And when I change another, it will start at the origin 0 point. Okay, part 3 is PWM. PWM output the on time specified in S1. Sorry. Wait a moment. Sorry. Okay. The PWM first output the on time specified in S1 and the cycle pulse in S2 to the output destination specified in D. So I think PWM everyone should be familiar with. It is a control method by changing the dice width of the pulse signal. There is just the 3 parameter in here, and let's see the demo. First, we set the on time in 100, and the cycle time is 300. So the duty also. The duty cycle is the duty cycle is 100 here, 300. This is the duty cycle in here. You can check in here. And in the Wecon PLC, we have 2 modes about PWM. This is the one mode. And the second mode is permeable mode. It means we can set the duty cycle in the first parameter. It's different from the last mode because the last we set the on time in the first parameter, and the permeable mode we set the duty cycle in the first parameter, and the second S2 parameter is the same. It's the cycle time, and the D means the output, pulse output. Okay, let's see. First, we set the 100. 100 is the duty cycle, and the cycle time is 300. So it means the 100 of 1000. This is the turn. This is the turn on time, and the fourth part is PLSR2 It means the multi-speed positioning. In this in this instruction, the ls and PLSR2 instruction set parameter in the form of a table and originate relative and absolute position pulse instruction according to the specified pole, frequency, running direction, and acceleration or deceleration time in the segments so that the servo actuator could make a governor offset based on the current position. There is a three parameter. The first S means the parameter that address in an air with dn as start address. For example, if I set D0, so the address from the D0, if I set the D10, D100, D100, D200, there is a different starting address. D1 means the device Y number of output pulse, and D2 means the running direction of port or bit available. Okay, let's see the table. First one, for example, if I set start address is D0. Okay, so D0, it means the number or the number of pulse segments. If I, for example, if I want to set the three 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 speed segment, so we need to provide D0 to 3 and D1 is reverse, so we know we can ignore this parameter, and D2 means the D2 and D3 means the first segment pulse frequency. So this is the speed. D5 and D4 and D5 means the number of pulse. For the first, pay attention to this is the first segment is because we have the three segment, and the D6 there is the first segment waiting condition. There are six type. If we set D6 to 0, it means the pulse sending complete, and so we can choose the 1 to 5. 1 means the waiting time, 2 means the waiting signal, and on overrated. 3 means the waiting signal of effective. 4 means the trigger signal rinsing age. 5 means the trigger signal falling age. And D7 means the first segment waiting resistor type. If I choose D6 to the 1, okay, let's see. If I choose this one, waiting time, I choose the D6 to 1 waiting time. So I need to choose this. Check here. Waiting time, we need to choose the 0 is the D resistor or is the consistent. For example, if I need to input one D100 is D100 is 100 million seconds. So in this demo, I need to choose D7 to 0 because 0 means the D resistor, and we need to set at D7, D8, and D9. This is the consistent value or waiting resistor number. because we choose the waiting time in here. So this is the consistent. So this is the waiting resistant number. If I need to use the D100, so we need to set the D8 is 100. This 100 means here is value, and then we can set the waiting time in the D100 per register. So if I choose the D7 to 1, it means the consistent. So we can set the waiting time directly in the consistent value in the D8 and D9. And the D10 means the first segment operation mode. 0 means the relative, and 1 means the absolution. It's the same. The logic is the same. The DDRVI or DDRVA we just heard in introduction before. And this one is the nth segment pulse frequency. For example, because this is just the second one, so if I need to set the two speed segment in here is the D0 at 2 and at the 2. Okay. So this means the D12 is the second. D12 is start about the second speed. For example, so the D3 speed is also follow the formulate by this. Okay, let's see the demo. The first, for example, we need to set the three pulse speed and the pulse frequency of the first segment is 200 sorry 220, and the number of the pulse is 200 20,000, sorry, 20,000. The speed is 20,000 hertz. The number of the pulse is 20,000. So and the waiting signal is M2. So this one is the first segment. The second segment is we set 100 we set 10,000 per, this is the frequency, 10,000 frequency speed, and the number of the pulse is 40,000. So this one is the two segment. And finally, 3, the frequency is 60,000, and the number of the pulse is 60,000, and with no waiting condition. So this is about 3 segment. Let me feedback the table. First, okay, this is the frequency, and D0 is the start address, and the 3 means the 3 segment speed. So this is data from the segment 1, and this is need to waiting signal is M2. Okay, let's feedback. First we need to waiting signal. Waiting signal is here, 2 or 3. For example, if I choose the true, true means the waiting signal and the on await. And then I need to set the first segment waiting resistance type because we choose the waiting signal. And then now we need to set D7 to 0 means the X bit register, 1 means the M bit register, 2 means the S bit, 3 means the Y bit. The requirement is M bit, so we need to set 7 D7 to 1 means here, and we need to set the M2. This 2 means we set the DH. First set D0 to 1, choose the M bit, and the second set the DH to 2. 2 means the M. 2. So this is the set K1 to D7, K2 to D8. And the second segment, we need to set the waiting signal is X2. X2, okay, feedback. First, we need to choose the waiting signal, 2 or 3. For example, if I choose the waiting signal is 3, means the off is effect. And then I need to check. I need to set the X register. So in this case, in the second speed, we need to set S7 to 0. 0 means the X speed, and the registers is S2. So this 2 we need to set in as here. So DA is 2, it means the 2, S2 register. That's feedback. So this is about set the waiting signal. And if I set the there is with no waiting conditions, we just set the K0. We set 0 to the D22, 26. Okay, this is the demo. You can check. First, if the signal is received in advance and it will not deceleration to stop and the directory acceleration and the deceleration to the specified speed of the next segment. For example, X2 slow variable is received during optional. So let's see this demo. But when I trigger, first the segment, and it will be waiting. The M2 is the waiting signal. X2 is a third signal. So the totally false number is 20,000 at the 40,000 at the 60,000 and